that you want to study insertion sort. We have studied this algorithm yesterday, so let us make the revision for the same. Here we have to initialize j is equal to 2 because we are dividing the array into two parts, the first element and the rest element. The first element is said to be always sorted, while the rest elements are always called as a unsorted. Therefore, your j will run from 2 to n. Here n is equal to 8. So what you are going to do, you are going to go with the key element. Here a of 2 means this is the key element, and this will be compared with this section. And if it is okay, means if you want to go with the ascending order, and if this number is less than this number, then you are going to keep it as it is. But if it is not so, you are going to replace the position. Similarly, at second iteration, this will be sorted group and this will be unsorted group, and A3 will be key element, and you are going to compare the key element with the sorted content. Like A3 will be compared with A1 and A3 will be compared with A2. Now, if let us consider the case if A3 is less than A2 but greater than A1, so that should be placed in between this value. So A3 will replace A2 and A2 will be shifted by one position back. So this is the code for the same. Now let us analyze this algorithm. Let us analyze this algorithm. Okay. Now based on this algorithm or based on our input value, we are going to divide, or we are going to look three different cases. The first one is the best case, second one is the worst case, and the last one is the average case. So let us analyze these cases straight away. But before analyzing these cases, let us understand this algorithm. Now, if you are going to work with this algorithm, so let us go statement by statement. Now, let us consider this is your algorithm. Okay, now let us consider this line. You want to go from place second to nth place. So definitely this is a very compulsory line. So I will put it with some green mark as it is compulsory, because every iteration is going to follow this line. Fine. So first it will be 2, then 3, 4, 5, 6, 7, and 8. Later on you have to select key element. So that element will be key element. So at this position, if j is equal to 2, what will happen? A of 2 will be key element. If j is equal to 3, what will happen? A of 3 is equal to key element, and so on. So again, I will say this is the important line, or this is the compulsory line. Again, let us go forward. If I will be assigned like that, j minus 1. So what will happen over here? Because you want to compare the numbers, therefore this is also compulsory line. This is also compulsory line, because you are, if the number is A3, or suppose if the number is A5, and suppose this is the sorted array, so A5 will be compared with A1, A5 will be compared with A2, A5 will be compared with A3, and A5 will be compared with A4. So every time you are going to perform this action because you want to compare the element. Now, while comparing the element, you are going to check whether it is greater than 0 or greater than key element. Means if A1 is greater than key element, then you are going to perform the shifting. Otherwise, you are not going to perform the shifting. So again, this line is the compulsory line. So this line is the compulsory line. Now, if this condition is satisfied, what will happen? You will enter into this loop. Otherwise, you will not enter into this loop. So these lines are mandatory lines. So these two lines are mandatory lines. Why so? Because if the condition is satisfied, then only they will go into this loop. Otherwise, they are not going to go into this loop. Therefore, these lines are not compulsory. If the condition is not satisfied, your program is going to skip these lines. Therefore, I am marking these two lines with red. Now, again, you're going to, what you're going to do? You're going to perform, you're going to select the next element. Means after completing this element, what you will do? You will go for this element. So a of I plus 1 is equal to key. So this is again compulsory. This is again compulsory. So how many compulsory lines are there? 1, 2. This is the comment. Okay, this is the comment. So if you want to consider it, you can consider. If you don't want to consider, don't consider. This is third line. I will not consider this line as of now. This is the fourth line. This is not the compulsory line, so I will not calculate. This is the fifth line. So total 5 lines are compulsory lines, whereas this 1 and 2, the 2 lines are not compulsory. Means if the condition is satisfied, then only these lines will come into the account. Otherwise, these lines are not going to come into the account. So this is all about your insertion sort. Now let us understand the logic behind it. Okay, now let me shift. Let me come to this board. Okay, now what I will do, I will select some elements. So let it be 2. Then 4, then 8, then 5, then 6, and let it be 1. Okay, now I want to sort this array. Okay, I want to sort this array. So how should I go? So I will divide this array into 2 groups. Here this element will be sorted and this will be unsorted. Okay, now my j is equal to 2. Okay, so what will happen? This 4 will be compared with this 2. Now here I'm going to satisfy the condition. So what will happen? You are not going to perform any transaction over here. So it will be as it is. So I will write again 2, 4, 8, 5, 6, and 1. Okay. Fine. And now the line will be over here. So this is your sorted and this is your unsorted. Now your j will be equal to 3. So this element will be compared with this 2 element. 6 is not less than 2 and 6 is also not less than 4. So it is again going to be same. So 2, 4, 6, 5. Sorry, this is the 8. 2, 4, 8, 5, 6, and 1. Okay, this is 8. Fine. Now this is your sorted array, whereas this is your unsorted array. So now 5 will be compared with this section. So now the j will be equal to 4. So how can I go? 5 will be compared with 2. The 5 is not less than 2. The 5 is not less than 4, but the 5 is less than 8. So it will be at the 8th position. So the next array will be 2, 4, 5, 8, 6, and 1. Okay, and now the line will be after 8. So this is your sorted array and this is your unsorted array. Now let us go to the next section. 6 is going to be compared with sorted section. So now the j is equal to 5. So 6 is less than 2. No. 6 is less than 4. No. 6 is less than 5. No. But 6 is less than 8. So 6 will take the position of 8, and 8 will move one side down. So it will be like this: 2, 4, 5, 6, 8, and 1. Now this will be your sorted section, and this will be your unsorted section. Now j will be equal to 6. So what will happen? 1 will be compared with 2. 1 is less than 2. So 1 will take the position of 2. Then every number will move to their left, or you can say every number will move to their right, means this direction. Okay, so 2 will take the position of 4. Okay, so the numbers will be like this: 2, 2, sorry, 2, not 2, 1. 2 will take the position of 4. 4 will take the position of 5. 5 will take the position of 6. 6 will take the position of 8, and 8 will take the position of 1. So now this is your sorted array. This is your sorted array. So this is all about the insertion sort. This is all about the working of insertion sort. So any query in the working? Okay, fine. So let us move ahead and let us go for the analysis. Now we have understood the working. Now let's go for the analysis. So before analyzing that function, we have to remember some basic fundamental things. So we will read those things. The first one is the initialization. What is the meaning of initialization? Nothing but the starting of that particular function. The next one is the maintenance. Maintenance means you need to count the iteration of the loop. If the count is less, then you have the high maintenance. If the count is large, then you have the low maintenance. And finally, after getting a proper output, there should be the termination. So every loop or every function is going to perform the 3 basic fundamental conditions: initialization, maintenance, and the termination. Initialization is nothing but the starting of the function. Maintenance is nothing but counting the loop, and the termination is nothing but ending actually your loop and getting the particular output. Now just see here. Initialization. Here, this is your input array, and you have to initialize j is equal to 2 because you want to run with 2. Okay, so initialization will be at equal to 2. So though if you have 6 numbers, the iteration will run for 5 numbers. Though if you have the 6 numbers, the iteration will run for 5 numbers. So now you can say that if you have n numbers, your iteration will run for n minus 1. If you have n numbers, your iteration will run for n minus 1. Now what about the maintenance? Maintenance is nothing but the counting of the loop. That we will see further while making some calculations, because just now remember one thing: it is nothing but the calculating the loop. It's a very simple definition for the maintenance. And the termination, the entire, if whenever you're completing the entire procedure, there will be termination with getting the proper output, because a proper output is a necessary thing. And if you want to go for with the success of that algorithm, then you should get the proper output. Therefore, the termination is also important thing. Now, let us understand, before doing this all things, let us go to the back. Okay, now let me explain the cases that we have discussed just 5 minutes ago: the best case, worst case, and the average case. The best case means if you are getting a less number of time and if you are getting a less space, you will say that this is the best case. If you are getting large number of size and large number of time, then you will say that it is the worst case. And if it is in between of them, it is referred as average case. So here I'm writing three cases: best, worst, and average. You are going to calculate the performance of the algorithm in the term of time and space. If you require the less amount of time and if you require the less amount of space, then what will happen? It will be the best case. And if you require the large amount of time and large amount of space, it will be worst case. And if you are getting some intermediate time, it will be average case. Now let's move ahead. Let's move ahead for the next point. Before proceeding, let us consider for every execution we require 1 KB of space and we require 1 second for execution of any one line. So for this algorithm, what will happen? On an average, 1, 2, 3, 4, 5, 6, 7. We will be having these 7 seconds for execution of this function and 7 KB space for execution of this algorithm. So what will happen? Just see here. So on an average means it is not like that exactly 7 seconds is required to execute this algorithm or 7 KB is required to execute some numbers. Okay, now we are done with time. Now let us focus on this space, 1 KB. Now for every execution we require the 1 KB space and also we need to store this number. So let us consider we are going to store 1 KB space per number. 1 KB space per number. So if we have the 8 numbers, we will be having 8 KB for the number and 8 KB for the number, and also we require 1 temporary variable because we are going to shift the position. So total 9 KBs are required. So if you consider, so total there, if there are n numbers, so n plus 1 plus 7 spaces are required. So total n plus 8 spaces are required. So total we can say that n plus 8 KB is required to execute this algorithm and 7 seconds is required to execute this algorithm. So any query in this dimension? Any query in this dimension? Or anything that you have not understood? Any query? Now let us move ahead. Now, how can we reduce the execution of this program? How can we reduce the execution of this program? The first way is, let us find out the loop. Where we have loop, so this is the loop. This is the loop. So every time this line is going to execute, means if you have the n numbers, so this line is going to execute for n minus 1. Okay, but if this condition is not being satisfied, then what will happen? This code will not enter in loop. This code will not enter in loop. Okay, so you can reduce these 2 lines. So you can reduce these 2 lines, and rest lines are quite compulsory. So you have to focus on the loop. You have to focus on the loop, and you need to reduce the number of statements, or you need to skip all the number of statements in the loop. So how you can reduce? So how you are going to reduce? So what you have to check? You have to check this condition should not satisfy. What you have to do? This condition should not satisfy. Means this is the definition for your best case. So this is the definition for your best case. Means if the loop condition is not being satisfied, it will be best case. If the loop condition is always satisfied, it is defined as the worst case. And if there is any intermediate scenario, it will be average case. So I repeat, if this condition is not satisfied all the time, it is referred as the best case. If the condition is satisfied every time, it is referred as a worst case. And any intermediate scenario is defined as average case. So now, suppose if I want to ascend the numbers, so let us input the array. So I have I have three examples of the array. So let us consider 2, 3, 4, 5, 6. 3, 2, 1, 5, 6. 6, 5, 4, 3, 2. So let us consider the first case. In this case, we are going to assign the number in ascending order. So we have to check whether 2 is less than 3, 3 is less than 4, 4 is less than 5, and 5 is less than 6. So at every iteration, this execution is not going to be satisfied. So every time this array or this example is going to skip these two lines. So this is referred as the best case, because you're not going to execute these two lines for all the time. Now let us focus on the second example. 3, 2, 1, 5, 6. 3 is not less than 2. So here this condition will be satisfied. So 2 will be here, 3 will be over here. 1 is not less than 2, and also 1 is not less than 3. So again 2 times this condition will be satisfied. But later on this condition will not be satisfied because 5 and 6 are greater than 1, 2, 3. So this condition will be executed for 3 times. So total 1, 3, 3, 3, 2, and 2. Okay, because this is the exit time. Fine, this is your exit time. So 3, 2, 5, 7. So total 7 times this loop will be executed. Total 7 times this loop will be executed. So this is referred as the average case. But the same case is not applicable for case number 3 or the example 3, 6, 5, 4, 3, 2, because every time you have these two lines are going to be executed. Therefore, this is referred as the worst case. Therefore, it is referred as the worst case. So any doubt? So any doubt in this scenario? Fine. So let us move ahead now. And now we will go to the actual analysis of insertion sort. I think all the concepts are clear. So now this will be quite easy to understand. So let us go by one. First line, for z is equal to 2 to n. Let us consider the cost is equal to C1, and this will be executed for the n times. Okay, let us consider this will be executed for n times, because for 2 to n it will be executed, and there will be a number n plus 1. For that particular value, this loop will be rejected. So total loop will run for 2 to n plus 1. Okay, kindly understand this scenario. Definitely the loop is going to run for 2 to n. For all this kind of condition, for all this condition, this loop is going to be satisfied. But after the last iteration, when the value is equal to n, this value will become n plus 1. So again, this loop is going to execute, and at this time, this loop will be failed, and you will be out of that loop. Therefore, this loop is going to execute from 2 to n plus 1. Therefore, the times is equal to n, not n minus 1. So kindly understand this scenario. Now, if the loop is running for n times, the elements are going to run for n minus 1 time. If the loop is running for n times, the inner elements are going to run for n minus 1 times, and the cost is equal to C2. This is the comment. This is the comment. So it is going to execute for n minus 1 line, but the cost is equal to 0. But the cost is equal to 0. The fourth line, again, we don't have any loop beside the for loop. So C4 will be cost of this line, and n minus 1 is the number of times that line will be executed. Now this is a different case. This is the actual different case. Now for execution of this line, you require cost is equal to C5. For execution of this line, you require the cost is equal to C5. But how this expression is evaluated? But how this expression is evaluated? So let us. So what I will do, I will simplify this statement. So just concentrate on this statement. What is this statement? Summation j running from 2 to n t of j. Summation j running from 2 to n t of j. So t2 plus t3 plus t4 plus up to tn. Okay, now what is this scenario? So let us consider a number 2, 4, 6, 5, 7, and 8. Okay, let us consider this example. Now I want to explain this line. Fine. Now just see here, this will be the sorted element and this will be unsorted element. Now just check here, 4 is going to be compared with 2. Okay, so 4 is going to be compared with 2. So this number of iteration will be T2. Now if it is sorted, then line will come over here. Then line will come over here. Now this line you have to this time you have to compare 6 with 2 and 6 with 4. So it will be T3 because you're going to add one number for the comparison. And later on, if you found something in it, then you are going to shift. Okay, so this is your T3. Then I will remove this line. And again, this is sorted, this is unsorted. 5 will be compared with 2, 5 will be compared with 4, and 5 will be compared with 6. So this is your T4. Every time you're going to increase number by 1 at every iteration. So what will happen now? Now here, 5, you have to insert 5 somewhere here. So the numbers will be like this, 5 and 6. So this is your actual array. Again, for 7, you're going to compare with 2, 4, 5, 6. So again, it is T5. And then 8 is going to compare with 2, 4, 5, 6, 8. So again, it is T6. So what is going to happen over here? Just see here. For the first iteration, you're going to perform T2 steps, which is exactly equal to 1. At the second iteration, you're going to perform 2 steps. So T3 is equal to 2. At the third iteration, you're going to perform the 3 steps. So it is equal to 3. At the fourth iteration, you're going to perform 4 steps. And at the fifth iteration, you're going to perform 5 steps. So T5 is equal to 6. How many total number of steps you are performing? 1 plus 2 plus 3 plus 4 plus 5. So in other words, T2 plus T3 plus T4 plus T5 plus T6. So you can say that the summation is running from 2 to 6. Okay, so the summation is running from 2 to 6, where T of I. Now this 6 is not, how many numbers you have? 1, 2, 3, 4, 5, 6. So 6 is equal to n. Therefore, it is replaced by n. So therefore, this statement is j running from 2 to n, T of j. Any query? Any query in this statement? Fine. So let us move ahead. Now, definitely, just see here. If you are working with t steps, then it will be something t of minus 1. Because every time if the loop is running for n times, if loop is running for n times, the inner statements are going to run for n minus time. So loop is going for to run for tj time. So inner loop will execute for tj minus 1 and the cost is equal to c6. Similarly, you're going to do for the second statement and final statement. If as it is not in the loop, the cost will be c8 and the times will be n minus 1. So now the total time required, that is the time complexity, is defined as C1 into n plus C2 into n minus 1 plus, this is 0, so neglect it, C4 into n minus 1 plus C5 this element plus C6 this element plus C7 this element plus C8 into n minus 1 this element. So just see this. It is nothing but the multiplication of this number and addition of this row. So C1 into n plus C2 of n minus 1 plus C4 of n minus 1 plus C5 summation j running from 2 to n tj plus C6 summation j running from 2 to n tj minus 1 plus C7 the summation j running from 2 to n tj minus 1, and the last one is the plus C8 of n minus 1. So this is the formula for time complexity. This is the formula for time complexity. So now what I will do, let us understand the good cases, best cases, and intermediate cases. Okay, so I will draw best case, worst case, and the average case. For the best case, this condition is not going to satisfy. So for all the time, we are not going to execute these two statements. So the value will be 0 over here as well as 0 over here. So if you are making these two statements equal to 0, it will be your best case. Okay, any intermediate position will be average case. But this all is referred as worst case, because every time you are going to execute this statement, so this is referred as the worst case. Okay, just see here, we have removed the element, so you're going to get something O of n. So this is a symbol of the best case analysis. Remember this symbol, because it is a very important symbol, and O of n square is the worst case analysis. Okay, that is you have to remember actually, because if you want to solve that function, you can solve that function, but I don't think it is required moreover. So if you are remembering this term, that is fine. You can make the table for the same, or if you want to how you are going to remember, that's actually you just check out. But this is the worst case and this is the good case or the best case. Now See here, total n square by 2 comparisons are going to happen. Total n square by 2 comparisons are going to happen for these statements, and total n square by 2 exchanges are going to happen for this statement. If you are in the worst case, if you are not in the worst case, if you are in the best case, then definitely it will be 0. Then definitely it will be 0. So let us go with some insertion sort summary. The advantages: it is a good running time, and disadvantages: the running time is worst in worst cases and the average cases. Now let us see, we're not going to see the bubble sort today. Before that, let us understand, let us solve one problem. Okay, let us solve one problem so you will get the better idea. And let us calculate the time complexity as well as the space complexity. Okay, I will keep this algorithm. I hope it is visible, and I will write numbers. I will take 4 numbers only, so it will be very easy. 4, 3, 1, 7. This is the intermediate case. Okay, so here I'm going to divide this into the 2 parts: sorted and unsorted array. Okay, so let's go for the first iteration. So 3 will be compared with 4. So how? Here, from 2 to n, so loop will run from 2 to 4 because n is equal to 4, and the key element will be a of 2. So what is a of 2? So the key element is equal to 3. So it is going to compare with 4. Okay, so while I is greater than 0, so what is the value of I? Now I is equal to j minus 1. So definitely you're going to come over here. Okay, so I will be this value, j will be this value. So you're going to compare some j. If I is equal to 0 and a of I is greater than or equal to key, means a of y means what is the value? A1. A1 is greater than A3. What you're going to do? You're going to perform a shifting. Okay, so you're going to perform a shifting. So shifting will happen here. 3, 3, 4, 1, 7. Okay, so for this execution, now this is your sorted and this is your unsorted. So for this execution, how many lines you have executed? 1, 2, 3, 4, 5, 6, 7. So let us consider we require the 7 seconds. And how many space we require, because we're dealing with only 2 numbers. Fine. And the 4 numbers for the storing. So we can say that we will not use the numbers for the storing as of now. We'll add it later words by doing plus n or plus 4 like that. Now here we have to deal with 2 numbers with 1 temporary number. So we require 3 spaces or 3 kb. So 7 second time and 3 kb for the spaces. Now again j will be incremented by 1. Now the key element will be 1 and ai will be 3 and 4. So 1 will be compared with 3 and 1 will be compared with 4. So now 1 is less than 3 definitely. So 1 will take the position of 3. Just check out here. 1 will take the position of 3 and again I minus 1 means 1 will take the position of 3. So I will write down over here 1. 3 will take the position of 4 and 4 will take the position of 1. Now this is your sorted and this is unsorted. So here now you have done with this line. Fine. I is incremented by 1. So 1 second for this line. Key element you have chosen. So 2 second for this line. Third one for this line. You are shifting the lines. You are shifting 1 with 3, then 3 with 4 and 4 with 3. So this line will be executed by 3 times Okay, and 1 for the comparison, that is 4, 3, 3. Okay, got the point? Because you're shifting 3 lines. 1 in the place of 3, 3 in the place of 4, and 4 in the place of 3. And 1 is for the comparison. So 4, 3, 3. How much? 4 plus 3, 7. 7 plus 3, 10. And finally 10 plus 1, 11. So total 11 seconds are required. And how many spaces? This number 1 and 2 for array and 1 for temporary variable. So 4 spaces. Okay, now the 7 will be key element. 7 will be compared with 1, it will be compared with 3, and it will be compared with 4. We don't require any changes for the same. So again we will calculate. So I will write down here 1, 3, 4, 7. So 1, 2, 3, 4, 5, 6. Because you are going to compare the 3 numbers. So 4, 5, 6. You don't have to enter into this loop because you're not going to satisfy the condition. So 4, 5, 6, and finally 7. So total 7 seconds are required. And how many lines? So you see, you're not going to exchange anything. So only 4 spaces are equal because you don't require the temporary variable. So total time is 7 plus 8, 11, 18, 18 plus 7, 25 seconds. And total space is 3, 4, 7, 7 plus 4, 11 plus 4, that is 15 kb. So this is your time complexity and this is your space complexity.